Okay, so today in our packet, we are on day 4. So if you open your packet to day 4, if you have multicolors that you used on Friday, if you thought about bringing multicolors for today and you have them, I would recommend them. Remember on Friday, we talked about, this is my unit 1B. I need unit 2. We talked about on Friday, please stop talking, hypotheses and conclusions. Remember, the hypothesis is what comes after your if. Two angles are a linear pair, and your conclusion needs to be specific. So instead of writing they are a supplementary, we need to figure out what they are. We were talking about two angles. So the two angles are supplementary. So remember, when we write the conclusion separate, when we're identifying the conclusion and we're writing it out by itself, it needs to be written with a non-vague, with a specific subject. Thank you. All right. So, knowing that review from Friday, today we're going to change conditional statements. So the conditional I'm going to work with first to kind of introduce 4 new vocabulary words is if the measure of angle A equals 90 degrees, then it is right. What is my hypothesis here?
The measure of angle A is 90 degrees.
The measure of angle A is 90 degrees. Okay, so that's my hypothesis. The measure of angle A equals 90 degrees. What's my conclusion?
The measurement of angle A is a right angle.
Right, because we don't want to say just it is right, so we need to know what are we talking about. We're talking about that angle that we measured in the first part, right? So you could say the measure of angle A is right, or you could just refer to the angle, right? The angle A is right, okay? So for my conclusion, I almost wrote it in orange, my conclusion is angle A is right. You could be more specific and say angle A is a right angle. That would be fine. But you don't want to add too much extra stuff in there, because that's sometimes when we get in trouble, is when we try to add too many extra things. Okay? All right. So now we have 4 vocabulary words, 4 ways we can change this conditional. Okay? So the first one is converse, a conditional statement where the original hypothesis and conclusion have been switched. Okay? So instead of if the hypothesis happens, then there's a conclusion, we're going to say if the conclusion happens, then the hypothesis. So I know it sounds weird to say it that way, but that's what a converse is. The key word for converse, I always think about the word switch. If I remember the word switch, then I remember that I'm talking about converse. I try to keep these 2 words in my brain. Converse goes with switch. Converse goes with switch. Anytime I say what's the key word for converse, your answer should be switch. Very good. Okay? So I'm still going to have if. I'm still going to have then. But instead of if orange then blue, for me, I'm going to do if blue then orange, right? I'm going to switch those around. So I'm going to switch them. What was my conclusion?
If measure of angle A is right.
Angle A is right. So if angle A is right, then what's my conclusion?
It is 90 degrees.
Instead of saying it is 90 degrees, we should say it's what is 90 degrees. Its measure is 90 degrees. You can either say its measure is 90 degrees. You can write all that out, or you can just write it as then the measure of angle A is equals 90 degrees. You can write it exactly as it was in the hypothesis. You don't have to. A lot of times we will make the conclusion vague because it's easier to write, but you don't have to. Okay, if angle A is right, then the measure of angle A equals 90. Okay, or then its measure is 90. All right, right, so next, inverse. A conditional statement where the original, so again, we're always going back to this original hypothesis and this original conclusion, where the original hypothesis and conclusion have been negated. Do we know what the word negated means?
Proving wrong.
I learned this a while ago and I totally forgot.
So the negation of yes would be no. The negation of up would be, so it's kind of like opposite, right? So instead of saying is something, we say is not something, right? So what I think of when I think of a keyword for inverse, if I don't want to think of not, or I don't want to think of negate, because it's a harder word to think about, is I just think of the word not. Okay? So for the word inverse, if I ask you what the keyword is, oh, it's hard to see that when I highlighted it in green. I would go with not. Now, sometimes you're going to start with an original hypothesis or conclusion that already has a not in there. So what happens, let's say that angle A, it says, if it originally started with the measure of angle A is 72, then it is not right. Or then it is it's not right, right? Because 72 would not be right. When I put a not in something that already has a not, what happens, do you think, if you double negate something? It's going to become the positive result. So anytime you have two nots in there, you just change it to positive, right? Okay, hopefully that made sense. All right, so let's put nots in. Again, we're going to go back to our original order. So I am going to have if my original hypothesis, which I'm always writing in orange, then my original conclusion, which I'm writing in blue. I just need to figure out where to put my knots or how to say my knots, how to do the negation. So anybody know how to make an equal sign into a not equals?
Put a cross.
Yeah, you just put a cross through it. Okay? So when I do the measure of angle A equals 90, to say no it doesn't, I just say the measure of angle A equals not 90. Okay? So I can see right here that I did negate it. Okay, I said not 90. All right, then my conclusion is it is right. How am I going to negate it is right? It isn't right or it is not right. You can use contractions or not use contractions, however you want to do it. I'm going to say it is not right. So put my little not right there. I negated it. Okay? All right, contrapositive, a conditional statement where the original hypothesis and the conclusion have been switched and negated. The key word I like to think of when I'm thinking of contrapositive is the word both, because we're going to both switch it and negate it. So we're going to do the switch and the not. Again, starting from the original hypothesis and conclusion, we're going to switch them. So I'm going to do if, and I'm going to switch it. So instead of starting with my hypothesis color, I'm going to start with my conclusion color. Then I'm going to use my hypothesis. My conclusion is angle A is right, but I need to put a not in there. So what am I going to say? Angle A is not right. If angle A is not right, and so I negated it right here. It's been negated, and I'm going to switch it. Or I already switched it. Then, what am I going to put?
The measure of angle A is not equal to 90.
The measure of angle A is not equal to 90. Equals not 90. And so I can see I negated it right here. Again, I would recommend reading these out loud, especially the ones where you negate, because sometimes we put our knots in weird places. I have legitimately gotten answers that say things like, if the measure of angle A is not equal to 90, then not it is right. That's not where we put not, right? Or the measure of angle A is 90 degrees, then it is right not. Or it not is right. I get that not in all sorts of weird places, but as soon as you hear that out loud, you go, then not it is right. You go, wait, that doesn't sound right. So as soon as you say them out loud, you usually can hear if it doesn't sound right. Okay? All right, the last one, a biconditional statement. A biconditional statement, that's our last new vocabulary word today, is the statement that can be only written if both the original and the converse are true. Which means we have to go back and look at the validity of at least the original and the converse. So look at the original. If measure of angle A equals 90, then it's right. Is that a true statement?
Yes.
Yes, that is a true statement. All right, what about its converse? The conditional if angle A is right, then the measure of angle A is 90 degrees. Is that a true statement?
Yes.
Yes. Okay, and we could do that for all of them. We really only need those two, though. But if I look at the next one, the measure of angle A is not 90, then it's not right. True or false? True. If the measure of angle A is not right, then the measure of angle A is not 90. True. But really, we only have to look at these first two to see if we can write a biconditional. So because these are true, we can write a biconditional. As long as those are both true, the original and the converse, we can write a biconditional. All right, so the way we write the biconditional is we say the conclusion, if and only if, the hypothesis. Remember, your conclusion does not include the word if. So if I'm just starting with the conclusion, that means I'm not starting with the word if. Because you've got plenty of ifs in the middle in there. You don't need an if at the beginning. Okay? Remember, your hypothesis or your conclusion doesn't include the then. And there's no thens in the sentence. Your hypothesis doesn't include the if. There's going to automatically kind of be one in front of it. Okay? So we're going to start with blue. The blue conclusion. And usually there's commas. I don't know why there's not a comma typed in there. If and only if. The orange part. Or whatever color. Here's hypothesis. Almost said hypotenuse. We're not to triangles yet. Alright, what was my conclusion?
The measure of angle A is right.
Angle A is right. Angle A is right. I don't know why there's such a big space between my G and my HT. If and only if, what?
The measure of angle A is 90.
The measure of angle A equals 90. And your biconditional, if it can be written, it will always be true, because it's coming from two true statements. What this is basically saying is the only way in the whole wide world for an angle to be right, the only way angle A in the whole wide world for it to be a right angle is if it equals 90. That's the only way it equals it. Okay? That doesn't work for all angles, right? We wouldn't say angle A is obtuse if and only if, and then give a specific degree, right? That wouldn't make sense, because there's lots of different obtuse angles. Okay? All right, any questions on these new vocabulary words? Because we're going to practice doing this. Okay? Good? Look at my next example. Conditional. If the measure of angle A equals 42 degrees, then the angle is acute. What's my hypothesis?
The measure of angle A is 42 degrees.
The measure of angle A equals 42 degrees. What's my conclusion?
Angle acute.
The angle is acute, and since we know the name of the angle, let's be specific and say what its name is. What's its name?
Angle A.
Angle A is acute.
It's cute.
It's a cute little angle. Keyword for converse means?
Switch.
Switch. Keyword for converse is switch. So I'm going to do, instead of if orange then blue, I'm going to do if blue then orange. So if, which angle is acute?
Angle A.
Angle A.
If angle A is acute, then what do we know about it?
And measure of angle A is 42 degrees.
Then the measure of angle A, or you could say then its measure, if you wanted to write it out in real words, then its measure is 42 degrees. Well, we can just do the measure of angle A equals 42 degrees. Oops, I should have done that in what color? Orange. It's been switched-ish. All right, the next one. Write the inverse and determine its validity. Oh, we didn't determine its validity. True or false? If the measure of angle A is acute, then the measure of angle A is 42 degrees. Those of you who said false, why is it false? Right. Just because angle A is acute doesn't mean it has to be 42. Angle A could be 23. Angle A could be 87. Could be what?
1.
Angle A could be 1 degree, right? So all of those that I just said and that we said and that Sean said, those are all counter examples. How many counter examples do we need to say this is a false statement? 1. So this is false. What was my original sentence? What's its validity? This one is true. So just because our original conditional is true doesn't mean when I switch it, it's also still going to be true. Okay? All right. The next one, inverse, what's my keyword? Not. So that means I'm still going to go hypothesis and then conclusion. I'm going to say if my hypothesis doesn't happen. How do I say this doesn't happen?
If the measure of angle A is equals not.
Is equal to not 42? That doesn't sound right.
Equals not. Cross out. Just cross it out.
Equals not 42, right? So if the measure of angle A equals not 42 degrees, then what?
And it's not.
Then angle A is not acute, or then it's not acute, right? Then it's not acute. Okay? And sometimes I'll just remind myself that I did put the not in there so that I can see it, that I know it's there. Is that a true or false statement? If angle A is not 42, then it's not acute.
False.
False. What's a counterexample? Angle A is 50 degrees, right? Angle A, if angle A is 50, it's not 42, but it is acute, right? So that is a false statement. All right. Write the contrapositive and determine its validity. What's the key word for contrapositive? Both. So if, I'm going to switch. So I'm going to start with angle A is acute, but I'm going to negate it. So I'm going to say angle A is not acute. If angle A is not acute, then what? The measure of angle A is not equal to 42. Degrees. True or false?
True.
True. Does everybody agree, or can I find a counterexample? If angle A is not acute, that means it's what? There's three other kind of angles. Obtuse,
Straight.
straight. Oh, I missed one. Or reflex, right? That other one. Reflex. Where, and so if it's right, or if it's obtuse, or if it's straight, or if it's reflex, all of those, if angle A is any of those, well then it can't be 42, right? So this is a true statement. Alright. If possible, write the biconditional statement. If not possible, explain why. Can I write the biconditional statement?
No, ma'am.
Why not?
Because the converse and inverse are not true.
Right. Because which one's not true?
Converse.
The converse, right? If I look up here, it says a statement that can only be written if the original conditional and its converse are true. Well, the original is true, but the converse is not. So, not possible because the converse is false. Not possible because the converse is false. Okay? All right. Let's look at the next one. If points are in the same line, then they are collinear. What's my hypothesis?
Points are in the same line.
Points are in the same line. This is a longer sentence, so if you write really big, you might have to try to write a little smaller. Then they are collinear. What's my conclusion?
The points are collinear.
The points are collinear. Points are collinear. Keyword for converse? Switch. So if conclusion, what's my conclusion?
Points are collinear.
Points are collinear. So if points are collinear, then now my hypothesis, what are we going to say? Is it okay to use they over here?
Yes.
Yes, we can say if points are collinear. We've already said we're talking about points, so now I can say then they are in the same line. What's its validity, true or false? True. What's the key word for inverse? Not. So if we go back to the original order, points are in the same plane or in the same line. Where? How do I negate that?
They're not in the same line.
Points are not in the same line. So if points are not in the same line, then what?
They are not collinear.
They aren't or they are not collinear. And if you want, you can just note to yourself so you don't forget, I did indeed negate it. Points are not in the same line, then they are not collinear, true or false? True. Keyword for contrapositive? Both. So I mean to switch it and I need to negate it. So if, what?
The points are not collinear.
If points are not collinear, then what?
The points are not in the same line.
Can we say they?
Yes.
Then they are not in the same line. And if you want, you can underline your knots so you don't forget you did put them there. read it out loud to make sure they're in the right spot, so you're not saying they not are in the same line or they are in the same not line. You'd be surprised how I see this. True or false?
True.
True. It didn't ask me to find my validity for the original conditional, but in order to write a biconditional, I know the original and the converse have to be true. The converse is already true. We determined that. Was the original true? Yes. So can I write a biconditional?
Yes.
Yes. Conclusion, if and only if. Hypothesis. Ooh, I did want to add something. Go to the other side of the notes real quick before you start writing that. Sometimes, mathematicians, when we can abbreviate, we really like to abbreviate. So sometimes you're going to see IFF in a sentence. If you see an if with two F's, that is the abbreviated form of if and only if. So if you ever see that, that's what that means. That means there's no other way that could possibly happen. Okay, so if you want to, when we write this next one, instead of writing out if and only if, you can use your double F if. That's hard to say. All right. Should I start with my hypothesis or my conclusion? What's my conclusion?
Points are collinear.
Points are collinear. Notice I'm not going to put the word if. Points are collinear. I didn't need to put the word if there because there's already 3 of them right here, or 2 of them right here. I don't need any more. That's enough ifs. If and only if, my hypothesis. What was my hypothesis?
They are in the same line.
They are in the same line. I don't know why I capitalized it. That doesn't make sense. True or false?
True.
True. Your biconditional will always be true because it's coming from two true statements. Okay? Interesting fact, your original conditional and the contrapositive will always have the same validity. What that means is if my conditional is true, my contrapositive will also be true. Okay? Your inverse and your converse will always have the same validity. So if my converse is true, then my inverse will also be true. If my conditional statement is true, my contrapositive will also be true. Those are always the same. But if my conditional is true, we've already seen an example where the converse could be false, even though the original was true. The converse and the inverse will always have the same validity. So if the converse is false, the inverse will be false. Those two sets of validities are going to be like 90% of the time what you're going to come across. It's either going to all be true or it's going to be true, false, false, true. Occasionally, your teacher is really strange and she will give you a false conditional, which means your contrapositive would be false. So if you're given a false conditional, your contrapositive will also be false. If your conditional is false, your converse could still be either true or false. You have to switch it and look at it and decide. So it could be true, it could be false. If the converse is true, then what do we know about the inverse? It's going to be true. If the converse is false, what do we know about the inverse?
False.
It'll be false. So those are the 4 validity outcomes you could have. They could either all be true, true, false, false, true, false, true, true, false, or all false. Okay? Oops. Any questions on any of those? And any of the vocabulary words for today? Okay. Your assessment or assignment is in Schoology.